Hello and welcome to the session. In this session we will discuss another method of clustering called as based on density. So in this discussion we will discuss what is density based clustering. We will discuss a particular type of algorithm based on density based method, that is DBSCAN, in detail. So let's first understand what is density based method. Now density based kind of clustering, it works very much the way that we as humans think. So if you observe this diagram, you have the data points, some data points which are gray in color, some data points which are yellow in color, and some data points which are blue in color. As humans, we will try to cluster all the yellow data points together and all the blue points together. So why did I cluster the yellow data points is based upon the attribute, that is one, and also since they're all very closely spaced with each other. In the same way, I have grouped blue together based upon the color, which is also an attribute of the data point, and also because they're all densely spaced to each other. Why I did not group the gray color data points is because they're not densely placed to each other. So that means they're very far away and randomly placed, and hence we did not put that into any kind of cluster. So the same way density based algorithm works. So we have seen k-means clustering in the last session, which was centroid based. And what happens in k-means clustering is, one thing is the shape of the clusters are specific. Normally it is spherical, and also it was centroid based, and it does not distinguish between any data point, right? Even outliers would be grouped into a cluster. Whereas in density based cluster, right, the advantage is you identify the outliers which can be of noise, and that would not be put into the cluster as has happened with these gray data points. And also the clusters shape need not be spherical. As you can see here, the shape of the clusters is taking the last data points of yellow. So basically you have a very arbitrary shape, so which is another advantage. Now density based methods, as the word itself says, here it we do the clustering based upon the how densely paced the data points are. So basically it's based on the concept of density of a region. So density of region represents the region where many points are above the specified threshold are present. So let's say I say the minimum number of data points that I need to have or to form a cluster is 70. So here if you observe this cluster, it is definitely more than 70. So I specify that to form a cluster you need to minimum have 70 data points. So more than that, when you have data points which are close related to each other, then the cluster is formed. So clusters are formed based upon the dense regions of the objects. So basic principle of density based method is it's based upon the local distance of neighbors. So as we will see the algorithm next, where we will see the neighbors, we find the distance with respect to the neighbors and make the clusters. So the main advantage is it can handle real world data irregularities. In real world data we will be definitely having lot of noise, lot of outliers, so that should not be put into a cluster. And the second one is the shape of the cluster need not be spherical, you can have arbitrary shape, so that's another advantage. So a very popular density based method of clustering is DBSCAN, which stands for density based spatial clustering of application with noise. Now before we go into the algorithm of DBSCAN, let's try to understand some important parameters with respect to DBSCAN. There are two important parameters that you need to know, that is epsilon and m. So epsilon is basically the radius and m is the minimum number of points that you need to have within a cluster. So if you see this diagram, let's say these are the data points I have. I have some blue color data points, I have some red color data points. So let's say this is one group. Okay, this is one cluster. So basically epsilon is the radius of the cluster. Okay, so it defines the radius of the cluster. And if the distance between 2 points is less than or equal to epsilon, so I have a data point here, okay, and have a data point here. If the distance between these 2 points is less than or equal to the epsilon, that is the radius, then that would be put into one cluster. So you define the radius, right? Let's say the distance from this data point to this data point, it's natural that it is more than epsilon, and therefore they do not belong to this cluster. Let's say the distance from this data point to this data point, is it less than epsilon? Yes, and therefore they belong to the same cluster. So basically epsilon helps to define the size of the neighborhood. In simple words, it's nothing but the radius of your cluster, as you can see in the diagram, but basically it helps us to define the size of the neighborhood. Okay, and the second one is minimum number of points, right? In simple terms, M is basically going to tell how many data points minimum should be there within one cluster. So let's say I say here in this diagram minimum points is 6. So how many are there in this cluster? 1 2 3 4 5 6. I have 6, which is fine. In this cluster I have again 6. So minimum data points that you need to have within a cluster should be 6. So that is what M stands for. So basically this is the minimum number of points required within the epsilon radius, right? Because epsilon is the radius to form a dense region. And some rule of thumb we need, right? How do you set the minimum number of points? So the rule is M should be greater than or equal to D plus 1, where D is the number of dimensions in the data set. So you can use this rule to define the value of M. But generally M is always set to 3, right? For most cases minimum value of 3 is recommended. Minimum 3 data points should be there to form a cluster. So the general idea behind this epsilon neighborhood, why I am saying epsilon neighborhood is, if I as I told you already, if I have to identify the neighbor, right, I say it is a neighbor if the distance from between the two data points is less than or equal to epsilon. If the distance is less than or equal to epsilon, I say it is a neighbor. Otherwise it's not a neighbor. So that's the general idea we use to form the clusters. Now coming to the, again, to understand the neighborhood concept in a better way, in this example I am just taking a two-dimensional space. So this is a two-dimensional space. See the figure 1 where I have some red points and there is only one blue point. Okay, so in the two-dimensional space, the epsilon neighborhood of a point P is the set of points contained in a circle of radius epsilon centered at P. So this is my point P. I need to find a cluster. Now in this case we are taking a spherical cluster. It need not be spherical always. It can be any shape. So let's say this is my cluster. So I have my radius here. The radius of this green circle is nothing but epsilon. Okay, so let's say I have some 100 data points here. The red data points are 100 and P is a point. Let's say it is at 3, 2 location. Now first you have to consider what is the neighborhood of P. So I have to, let's say I have defined the epsilon, I have defined the radius as 0.5. So then you get this diagram. I have defined the radius as 0.5. So with the radius of 0.5, this is the shape of the cluster I am getting. So let's say green represents our neighborhood. So all the data points which are within this green circle, right, they all belong to this cluster. So if actually you see this circle, right, if you count, there are like around 31 data points in the neighborhood of P. So this is my point P. E has 31 data points. So in the sense, for the point P, the red data points within this green cluster are 31. So 31 red points are there within this green circle, and the neighborhood of this blue point P is 31 data points. So see this other diagram where we have reduced the radius for the same data point, for the same input. We have reduced the epsilon value to 0.15. I have reduced the radius. After reducing the radius, we can measure, right? 1, 2, 3. There are 3 data points in the neighborhood. So that was just an example of how do you identify the neighborhood. So neighborhood of point P. So in this third diagram, third figure, the neighborhood of point P, which is the blue circle, is 1, 2, 3. Now coming to the key idea of data density, also very important that you understand the concept of density here. So let's say I have a point P here and the epsilon is the radius. Okay. So how do you find the density? To find the density, the general math formula is you need to know the mass and volume. So what is the mass of the neighborhood? Mass of the neighborhood, in this case neighborhood is nothing but all the data points within the green circle. So basically mass is nothing but the number of data points within the neighbors. So let's say in this case I have totally 100 red points, out of which 31 are within the green circle. Therefore the mass is 31. Then you need to find the volume of the neighborhood. So you need to find the volume of the resulting shape of the neighborhood. So find the volume depending upon whatever shape of your cluster is. So once you find the volume, you can find the density by using the formula density is equal to mass divided by volume. So you can find the local density approximation as density is equal to mass divided by volume. Now let's see how dbSCAN works. Okay, now dbSCAN works by categorizing the data points into three types. Now I've been talking about data points, right, in this diagram. Now there are three data points that you need to know before knowing the algorithm. One is the core point. What is a core point? See this diagram here. All these circles are different clusters that I have. Now just observe the red circle, right? This blue points, the blue things are nothing but your data points. Now if you observe the red cluster, the point which is at the center, let's say, or at the heart of the cluster, that I'm going to call as the core point. As the word itself says, this one is the core point. It is the heart of the cluster. And as I said, any cluster should have minimum m number of data points. That is, minimum number of points, or m is nothing but the minimum number of data points that you should have within a cluster of radius epsilon. Now there's one more point called as border. Now the points here, this can also be called as a border because it's very much close to the border of the cluster red. So basically border points are on the edges of the cluster and they are not connected to the core points. Okay, so these points, border points, are within the epsilon radius. Because it's in the border, definitely it is within the radius, right? It is because it's, as I said, if a point is on the border of the core, let's say it is here, so that means it is at a radius epsilon, so it is still within the radius, but it doesn't have enough neighbors for themselves to be considered as a core point. It is on the border of the cluster. Though it is at the radius epsilon, it does not have enough neighbors, so therefore they reside on the edge of the cluster. The third one is the noise point. As you can see, this one is a noise point because it is neither a core point nor is it a border point. It is an outlier, right? So if I have a point here, if I have a point here, now these two things I have put it in a cluster, but I cannot really say that this green one is a cluster because minimum I am saying 5, but I don't have minimum 5 points for this to form a cluster, and therefore this becomes a noise. Right, it becomes a noise because minimum 5 data points are required to form a cluster, and therefore this cannot be considered as a cluster. So let's now look into how the dbSCAN algorithm works. So first step is you have to identify the core point. For each point in the data set, count how many number of points are within in the epsilon neighborhood. Right? If the count meets or exceeds m, mark that point as a core point. So I have so many data points, right? 1, 2, 3, 4, 5. Now how do I say which is the core point, which is going to be my center of my cluster? So for that I have to count the number of points within the neighborhood, right? I have to find the distance from here to here, here to here, here to here, here to here. Again you find from this to the rest. If the count meets or exceeds m, right, you find the distance. If the count meets or exceeds the value of m, I take that as a core. So from this diagram I will take this circle as the core point. Now you have to form clusters. So for each core point that is already assigned, that is not already assigned to a cluster, create a new cluster. So if it is not belonging, so this blue point is not belonging to any cluster, so I will make it as a core point and I will make a cluster by drawing a circle around it. Let's say in our case a cluster is a circle, drawing a radius around it by drawing a circle around it with the radius epsilon. The third point is dense connectivity. So the connectivity within the points is also very important, right? Let's say I have 2 points A and B, right? They are densely connected. So normally dense connectivity is, how do I say that it is densely connected? That is very important. So when I began the session, how do I make clusters? Based upon how densely they are connected, right? How the points are densely connected. So basically it's like a chain I try to identify, right? There are 2 points, let's say this is A, this is B, right? So I need to have a chain of points here within the epsilon radius. And if at least one point in the chain is a core point, then I can say it's densely connected. So let's say this is A, this is B. So I try to make a chain. When I make a chain, I got the core point here. So I can say this is densely connected. I'm trying to make a connection from here to here. So when I'm coming, I'm getting a core point again. So I can say that it is densely connected. Okay. Now if I try to do from here to here, right, there are no data points inside and no point which is a core inside. So they are not densely connected. So these 2 points are not densely connected. If I see from here to here, when I'm trying to see, there are no data points between them and there is no core point at all. So therefore they are not densely connected. So dense connectivity is if you're trying to establish a connectivity from, let's say, from point A to point B, you should have a chain of connectivity where at least one point there is a core point. And the fourth one is you have to label the noise points, right? All the other data points which are not coming under dense connectivity will be labeled as a noise. So when I'm talking about connectivity again, so if I'm talking about connectivity from one point to another point, because I have to establish the density, right? How densely they are connected. So 3 types of connectivity I can discuss. Direct density reachable. Let's say this is X, this is Y. If X is directly reachable from X to Y, right? So for example, in this, from X to Y, it is directly reachable, right? Then I say it's direct density reachable. Okay, if X is directly reachable to Y, then I say it is direct density reachable, or I say that X is in the epsilon neighborhood of Y. So definitely, right, in this diagram, X is directly reachable to Y, it is in the neighborhood of Y. X is in the neighborhood of Y. Or I can say Y or X is a core point. The second type of connectivity is density reachable. Point X is density reachable from Y if there are a set of core points leading from Y to X. Okay, so see this red diagram, red circle. I will say this is X is density reachable from Y if there are set of core points which are leading from Y to X. Now Y is a core here for this red circle, and therefore it is density reachable. The third one is density connected. 2 points X, Y are density connected if there is a core point Z such that this has to be X, such that X and Y, this has to be X and this has to be Y, such that X and Y are density reachable from Z. So if you observe this blue diagram, right, X and Y, if they are reachable from Z, right, then we say it is density connected. If X and Y are reachable from Z, then we say it is density connected. So these are the different types of connectivities we have. Now let's see the algorithm of DBSCAN. The first step is, so let's say this is my diagram. I have some 100 data points which are the red ones, and there is one point B for which I'm trying to do. Okay, now randomly select a point P. So let's say that point P is this blue point. Now compute the distance from P to all the other points. You have to compute the distance from P to all the other points. In step 2, find all the points from P with respect to its neighborhood. Okay, and check whether it has minimum number of points. I have computed the distance from P to all of them. Then I am finding which is in the neighborhood. So based upon that, I will mark that as a core point. So let me say I mark P as my core point. Now if this is a core point, then I will make a cluster based upon the epsilon value. Suppose this point is not a core point. If it is a border point, then I move it to the next point. Then if it is a border, then I go to the next point and mark it as visited. Now suppose this point is not a core point, it is not a border point, it is a noise point, then it is removed. I am not going to make it part of my cluster. Now you merge the clusters. Now this process of step 3, 4, 5 will be repeated, right, until, right, all the points are either identified as a core point or a border point or a noise point. So the key idea is you have to identify the points as either core or either border or either noise. So the advantages of DBSCAN is, the first thing is there is no need for specifying the number of clusters beforehand, unlike in a k-means clustering. The second one is it can detect clusters of any shapes. It is robust to noise because it's not going to take noise as a part of your cluster, and very few parameters are needed. So the complexity of this algorithm is big O of n log n, where n is a number of data points. So that's it for today's session. Any doubts, please let me know. Thank you so much, and please share the video and subscribe to the channel. Thank you.